Hello, and thank you for attending today's From Cradle to Grave, Enabling Business Velocity with Chef. My name is Jeff Belt. I am a Senior Principal Computer Systems Technologist, a very lot of words for electric janitor. I've been in Raytheon Technology, Missiles and Defense now for about 25 years, my current position for 8 years. In my role, I work to develop, incorporate, and design basically business cases, patterns of success, service models, anything that is required in my business. And our current goal is really to facilitate cloud adoption for our business, specifically my business unit, which is, again, Missiles and Defense. A little bit more about what my team and I do is we've enabled high performance compute through cloud for various platforms, including US Gov Cloud, Amazon Web Services, Azure, and of course our own private cloud environments. That includes infrastructure as code, deployment, sustainment, multicast networking in Amazon, engineering sandbox environments, and engineering environments, prototyping, and of course, monitoring. So we've got a variety of solutions, a variety of tenants involved in our cloud efforts. And what I really enjoyed about this was working with the various technologies, including our Chef suite of products. The benefits we've realized by Chef, though, were actually pretty wide. Everything from our image build processes when we were building our baselines, for whether it be for our VMware targets or Amazon targets, didn't really matter to us. And how we built those, how we configured those, and then of course, how we verified those. We also leveraged Chef in deploying those images, regardless of the source, whether it was our baselines or a program-specific image source, configured, verified, again, all with Chef. We continued using Chef in our monitoring, deploying those instances, making sure they are continuously watched, continuously checked, continuously reporting on any potential problems that might come up, not only from an operational perspective, but a compliance perspective, and not just an IA compliance perspective, from a configuration compliance perspective as well. We use that across multiple teams for that compliance insight. And then of course, always in the sustainment of those resources, you know, whether it be a VM again on Azure, Amazon, or on-prem. And what we really realized here not only was the fact that we were using our central repositories, but it was a debt reduction across those repositories that really gave us that benefit and sustainment, and allowed the teams not only to excel, but reduce that sustainment cost overall. We use some key technologies in our plan and in our roadmap and in our journey. Some of them, you know, had been shed early on, some of them have been picked up, and some of them have been replaced. Today, we're using Packer from HashiCorp to create our images, again, regardless of our source, whether it be a source from an Amazon AMI or an ISO image from Microsoft, doesn't matter to us, but also regardless of target, whether it's a target to do a physical deployment, a virtual deployment, whether it's in cloud or on-prem, we use our Packer to develop those baselines. We use Terraform to deploy those baselines. Again, another great tool from HashiCorp, allowed us to do a lot of different things. And initially what we're doing a lot of configuration in Terraform. Caused a lot of technical debt to be accumulated there and a lot of angst on a lot of our teams, but we managed to work through it. And as we matured, we started with compliance and configuration as code, which really ended up becoming our platform of choice. What was great about Chef was that we were able to not only do our configuration for information assurance, but our configuration for our application base as well. And that was the power that we got out of Chef. But we got it even further when we started looking at how we used Chef in building our images. So in here, we have all our code. Our Jenkins picks it up and it does our builds. But Chef is really the piece here. It does all of our configuration of these image builds. It is the heavy lifting. There's very, very little in Packer except running some scripts that execute our Chef. And Chef does all the configuration from patching the initial baseline sets to deploying initial applications to configuring said applications, everything that we need to do in these baselines. And it doesn't matter, again, what platform we were targeting, whether it was Amazon, whether it was Azure, whether it was VMware. Chef really was the driver behind our baseline images. And when we realized the power behind that, we took it to the next level. That next level was in our deployment. And I said earlier that Terraform did a lot of work for us initially and early on. And when we realized, we started using Chef and Packer, we said, well, why are we using two different code bases? Let's do our deployment again from code. Terraform's really good at doing some of these things, but let's let Chef do the heavy lifting again. So we integrated Chef and Terraform in this time. Again, it deploys and configures our IA, any applications that are going on top of those baselines, any associated configurations for applications. And this really enabled us to streamline not only the building, but the deployment. So our code base got collapsed where what we were building initially to what we were deploying, maybe out of sync. Maybe the image was 2 months old and it didn't have all the patches. Well, on deployment, Chef said, hey, you're missing patches, and it would deploy it. So we knew we were always up to date with Chef during deployments as well. And again, it did not matter to us whether it was Azure, VMware, Amazon, we didn't care. Chef did that heavy lifting for us and figured out where we needed to go. It was able to determine which platform we were on. So it was able to determine which drivers it needed, which customizations it needed based on the target platform. So in Sustainment, which we also had, this is the traditional model Chef provides. We've all seen this graphic. We use Chef in our Sustainment too. We don't try not to anyway. We don't log into our boxes to do a lot of major deployments. I do major system administrations. We don't log into our boxes to do a lot of system administration work. We try to avoid logging in. We do occasionally, but Chef does our major Sustainment work as well, all again through that code base. And it's the same code base, again, that builds our images, it deploys our images. So it handled a lot of the sustainment tasks as well. What was great about the sustainment piece is we got that same level of control for information assurance, for our applications, for any associated configurations, which really resulted in that labor reduction spend. So we have our three major technologies, our Packer, our Terraform, and our Chef infrastructure. From creating it, to deploying it, to sustaining it. And this was all fantastic. We got a lot of these building blocks integrated together. We got them running smoothly, and we saw a lot of value. Well, never satisfied like Apple and Steve Jobs was, so what? A lot of tools can do this. So we decided to take it to the next level. We built ourselves a self-service cloud portal, and we integrated all three of these tools into that portal. And that portal allowed our end users to do their own deployments without having to submit tickets to us. Again, regardless of the platform. Not only did we go and say, great, now we can do deployment, we said, let's monitor our deployments, and we integrated it into our monitoring systems. And at each step of the phase, each step from Packer to Terraform to portal to deployment to in the deployment itself and the sustainment, Chef is there all along the way. And what's great about this is it's the same code base. It's the same Chef recipes. It's the same Chef inspec. And this was one of the pivotal, oh my God, gotcha moments for us. Because when we realized that we started using Chef pretty much everywhere, by replacing self scripts in monitoring, by replacing deployment scripts that we were using to orchestrate Terraform and sustain those environments, we all of a sudden realized our technical debt dramatically just fell off a cliff. I mean, it was the quintessential, took a flying leap and dove off that cliff because Chef code was Chef code and it was the same code. And it was just really a question of, Well, did you run all the chef code up here when you built it? No, you really didn't, but you ran a subset of it. And that was what was great about the cookbook methodologies and being able to select and pick and choose what you needed to run. Our self-service portal was really an innovation out of our HPC project. And the reason I bring this up is because it shows you how seamlessly and easily Chef worked with it. And really that HPC project was to get HPC in cloud, but also to provide that capability for our end users. So what we did is we took this project that allowed us to let the users do that self-provisioning and take it to the next level, to take it so they could deploy what their configurations are, not just in HPC, but in any sort of instance deployment, whether it be workstations or servers or whatever they needed. So got a little demo for you of our SelfService Cloud portal, and I'll talk through this. Nice little video. It's about 3 or so minutes long. And what you're currently seeing in the beginning is this is the current deployments the user would have. There we go. So the users log in, they see their current deployments, and they can destroy those deployments if there are any. They can decide they're going to deploy new ones. And what we're going to do here is do a nice little deployment to show you what the user gets. Some costing and program information. Yeah, this is just bookkeeping paperwork. They select an instance type that they want. In this case, it's an Amazon instance type. They select the image that Packer went and built that is available to them. Some, options they can use like centralized home directories, things like that. Any alignment use cases they have. So if they have compute needs or GPU needs, they can do that. We're gonna use a general purpose instance here for our instances. And then we try to give them some costing estimations along the line so that they can know what it's gonna run them. Here, what we're gonna do, this is the kind of the cart. We're gonna do a Windows deployment and a Linux deployment just to show. And what this is going to do is actually show you the deployment itself. So behind the scenes, what this did was kick off a Chef cookbook that generated the Terraform configuration based on a template. That template then gets populated into Terraform, and Terraform gets run. And what you're seeing here is the initialization of Terraform. I'm not going to make you sit here for the whole 12 or so minutes that it took to originally deploy this. So it's going to speed up here in a second, and you'll be able to see the Chef code actually get executed. And there we go, there's Chef. So you can see here, it's actually skipping some resources because they're already configured as part of our baseline. It's executing some resources. It's populating all sorts of things like certificates, proxy configurations, you name it. This is a very basic deployment, so it's gonna go do some basic stuff. But you can see all sorts of registry settings and everything else that Chef is going and doing the deployment. Now, because again, this is the same code base we used to build the image, some of this may or may not have run in Packer to build the image, but it's also now running in deployment. It's the same code that's actually running in Sustainment too. So all of these settings that we're using to deploy this here as part of this request by the end user is being deployed in Sustainment as well. So all these settings are already out there. They're already in our production environment. But once this deployment is done, you can see we give the user their connection information, how they connect, what they need to know about the naming conventions for the connections, what various tools they might need, the little things that they can use to connect to these instances. And as you saw behind the scenes though, Chef was a key part of that entire configuration. It was the majority of the configuration to either ensure its compliance with our approved deployment or ensure its compliance with any IA configuration settings, zero-day exploits that we had to put in for mitigation, all running right out of the call from our Terraform. Again, with Terraform's configuration being generated by a template from Chef. So we took it to that next step after we got that deployment to our infrastructure monitoring, where we said, yeah, it's great that we can do all this image builds, we can do all this deployment, and we can do it with the user being able to self-service themselves. But so what? We still have no insight. So we said, we need the ability to watch our deployments for compliance. And I'm going to talk a little bit about IA compliance here because we all seem to have that anywhere we go, no matter what industry we're in. We can, I think, all relate. We leverage Inspect for our continuous compliance monitoring. Before an ATO, or for those not familiar, the approval to operate, we had a number of folks that would spend hours, days even, ensuring systems were ready for review. And whether that was an initial ATO or renewal for an ATO, because periodically we have to go through renewals, it was spending a lot of labor dollars to get that environment ready. And you can see we get a lot of systems in this environment in this particular page. It's going off the little screenshot here. After we integrated Chef Inspect, after we got to a point where our Inspect profiles were mature, that effort of an ATO renewal, which we just went through 3 of them, we continued as normal. We didn't have to go to the environment and say, hey, are we ready? Are we all patched? Do we have CLAM AV or malware scans running? Are they actually operating? Are their definitions up to date? We didn't have to do any of that. We knew what the state was. And we knew what that state was because of a little column right here that I'm highlighting. It's just a little green dot next to that box. And we know it's compliant because it's green. Well, what's behind the dot? Let's pull back the curtain and we can look at the dot. So this is an example of phase 1 where we had issues. We call it phase 1 because we did the rollout in 3 phases. Phase 1 was understanding our environment and the configuration compliance deltas that were involved. You can see here, right up at the top, we have a green dot again, but we have all patches applied. There are no patches missing on this box. But we do need a reboot here. It's saying you applied all the patches, but the patch isn't active. It needs a reboot. Inspect is able to tell us that. And then we have our IA compliance details. Even though we are not missing any patches, even though we do need that reboot, that's okay. We detected that. We are looking and saying, well, there's all these settings that are not set. We have 1 successful control, 0 control failures, and 1 control skipped. But we are running a second profile down here. That's our patches profile. And we have several controls we obviously have missed. In phase 2, what we did was we got ourselves cleaned up and we started cleaning up all of the configuration deltas. And in phase 2, we started melting those snowflakes around our environment so that we started looking, feeling, acting all the same when it came to our IA compliance. Everything was starting to be configured the same. We still had some failures, and in this case here, one of the failures we have is our malware scan. As we matured our profiles, not only were we doing configuration settings, not only was saying, oh, hey, the password's set to 60 days, you need 8 characters. Yeah, we took a step further where we were actually testing some of the operational controls of that box that our IA teams wanted. And in this case, it's the malware scan. What it's saying here is I expected in that malware log that I would see infected file 0. Well, okay. There are 3 potential outcomes here as to why that would not be. The first and most obvious one is you got an infection. No, that wasn't the case here, thank goodness. The second one is the log didn't have that line in it, so it could have been still running. Well, that wasn't the issue either. What it turned out to be in this case was the scan itself wasn't actually running. So when we dug into it, we figured out, oh, our malware scanner, yes, it was updating its antivirus defs. Yes, it was configured correctly. Yes, there was a cron job in there. And it was not running. Why was it not running? Because cron wasn't enabled. So really felt like a homer at that point. So we added to our inspect profile, hey, make sure cron daemon is running. In addition to making sure that the CLAM AV scanner job was there, making sure the defs were getting updated, all the other stuff. So we started learning where some of our deficiencies were in our environment. And then when we finally started fixing all of those, we got to a point where our known compliance state is good and our patching is good. So therefore, our IA state is good, and good is what we wanted. Now, one of the things to note is that we showed you deltas here where there were problems. The scripts, the tests that run out of this tool, the tool's Zymon, it's freeware for anyone who wants to go get it. We filter it so that we only show failures. There's a couple reasons for that. The big reason, though, being if I have to show every single thing in here, you're talking about, in some cases, thousands of lines. We didn't want anything to get lost in the noise. So what we said was, let's only show failures. Now, in the back end, all of the details, both the success and the failure, are available in a log file somewhere on the system that can be obtained. So security can go and grab that, but they can also look at this. But we only wanted to show failures. Again, this is a monitoring, not a reporting tool. So we wanted to make that a little clear, is this is monitoring. And we can monitor to a good known state. Because we got a good known state, our ATOs are granted pretty quickly. We know what inspect versions we're running. We maintain our inspect profiles. Anytime a 0 day comes out, very first thing we do is we evaluate the 0 day and say, how can we detect it? Is it something that, oh, the patch isn't there, the registry setting isn't there, the package isn't up to date? What is it? And we'll write the inspect for that and throw it out there. And we want to see the environments turn yellow or red, depending on the severity of the detection. And we know instantly where our environment's vulnerable. Yes, the monitoring system does protect against this data getting out to people who don't need it, but that's besides the point. But the inspect was a great example of where it really does not only provide us compliance testing, it provided us the insight into where we stood. Now, one of the questions you can ask is, why aren't you using Chef Automate? Well, we are using Chef Automate. We're just not using Chef Automate in this pipeline. What we use Chef Automate for is to make sure the health of our Chef automation infrastructure itself. And we use Chef Automate for generating the reports that we need, not the continuous monitoring of the environment. So slightly different use case. This is more for the sysadmin on the ground, more for the IA person on the ground, as opposed to the auditors who really need that detail in the back end, or the infrastructure admins who are responsible for the global monitoring of the thing. And that's where we use Automate. One of the other things that really we found, and this was a huge lesson that we learned the hard way, and I don't know why we had to learn it the hard way, because I've been in chef conferences for a number of years, and I know people have said, use central profiles, and I don't understand why. I just did not get that. We used a central, non-authenticated repository for our inspect profiles. This did three things for us. Not only did it allow us to run our inspect from the command line through Automate, Jenkins pipelines, our monitoring clients, but it also allowed us to have an open repository that now we have other folks within our organization who don't use our automation pipelines. They don't use our Packer. They don't use our Terraform. They don't use our Chef Cookbook, but they're grabbing our profile and running it against their systems and seeing whether they are compliant with the baseline security settings of the company. Now, I've been saying inspect profile. We have multiple inspect profiles. The two, I alluded to two. We have a patch profile, which is just the one out there, the Linux patch baseline, the Windows patch baseline. You can get those on GitHub. I believe you used to be able to get them on the Chef Supermarket. Those we take as is. We don't modify them. We just take them. We upgrade them as is. We have application profiles that get run. We have an IA baseline profile that gets run, and that's what we just saw was that IA baseline profile. We do have some, we do have a profile that checks to make sure that the baseline profiles are running. in there, but that is shown on our Automate because that's the health of an automation infrastructure. And to us, the central repository made it very easy for us to distribute these profiles to other folks. In addition to running them on local Windows boxes, local Linux boxes, we do now have one that runs on a headless appliance in the network through SSH. So that was really kind of a neat little endeavor. And we generate our compliance reports out of those compliance reports being whether they're for IA or the admin to know what state they are, depends on really where the report gets sent. Overall, though, the benefits we realized by Chef through our life cycle was from our image build process, regardless of platform, to the deployment of that build to regardless of platform. Our continuous monitoring and compliance, which you just saw, and our technical debt reduction. Because we use Chef in every phase of our life cycle, from our builds all the way through to our sustainment in life, it really reduced our overall workload to manage all of these various technologies from build to sustainment, and collapsed it into a single compliance as code capability that we could use in every phase of our life cycle, in every aspect of that life cycle, up to and including sustainment. We are working on and have some limited retirement of those. We have the retirement you saw through the SelfService Portal, but we're working on some sustainment code of Chef to go through and look at, here's all the systems in the infrastructure. Are they registered with property management? Here's all the systems in the infrastructure. What versions of the OS are they? For our configuration compliance with IA, for our engineering tools application folks, so they know what platforms they need to support. And we based it on really two different Chef ecosystem technologies: Chef infrastructure, which is infra server and infra client, and Chef inspect. Those are the bulk of what you saw today. We are looking at Habitat and seeing how we might be able to leverage that, although we don't have any real firm plans yet. But what we have seen is what we are using today is growing. What we are using today has certainly proven its worth. We have concrete financial cost reductions that we've been able to quantify, not shift costs. In my history anyway, what I've seen is people will shift costs. Oh, we saved money in our department. Yeah, but they picked up the bill. We actually said, well, we were spending 100 hours on sustainment, and now we are spending, and I kid you not, 20 hours in sustainment type of reduction. And it was all thanks to this use of Chef, infrastructure and inspect, and how we integrated those into the technologies that we talked about today. Thank you, everyone, for paying attention to me. I really appreciate your time. Have a great day.